Hello guys, welcome into grade 11 mathematical lesson, whereby we will be still continuing with the questions of Euclidean geometry, the riders, the circle geometry. So we will continuing since the previous lesson we left off in this question. Now we will be continuing from problem 10.2. So now back to our technique, DRCPT, the Dr. Cape Town technique. Oh, no, I'm sorry for that. Yes. Now we are saying DRCPT. The D is the diameter, R is the radius, C is the cyclic quad, P parallel lines, T tangent, right? Now, I'm going to ask myself if is there any diameter in this diagram. So, okay, let's have a look. Oh no, there's no diameter. Radius, no. Is there any radius? Oh yes, but this is the center of the circle, but we don't have to assume that. Now, this is why it is important for you to always first start reading the statement that you are given. Now, let's go through it. In the diagram, M is the center of the circle, so now we don't assume. We know we are given that M is the center of this circle, right? A, B, C, K, and T lie on the circle or on the circumference of the circle. AT is produced and CK produced to meet at N. Okay. Also NA, this one is equal to NC, this one. Okay. Good. Now, NCA is an isosceles triangle. Therefore, angle C is equal to this angle CAN. Okay. Now we are given that B is 38 degrees. Good. Let's go for D. Any diameter? No. R. Radius? Yes, there is a radius Km and MA. Therefore, Km here is equal to MAY because they are both radii. Okay. And then we have C, the cyclic quad. What is the cyclic quad? Cyclic quad is that quadrilateral with 4 angles and 4 sides, that of which those 4 corners or 4 angles touches circumference. So we have B, A, T, and K. Therefore, BATK is a cyclic quad. What are the properties of a cyclic quad that we know? Opposite angles of a cyclic quad are supplementary. They add up to 180 degrees. B plus T1 is equal to 180 degrees. Now we simply can find that T1 and this angle BAT plus this angle BKT is equal to 180 degrees. Okay, now which one can we say we can use? Oh, we have something like a bow tie here. Now we can use that theorem, angles in the same segment. But the only time you can use that theorem is if the corners of all the angles of your bow tie are all on the circumference. Right now, this angle is equal to that angle, reason being angles in the same segment. And this angle is equal to this angle, reason being angles in the same segment. Right? Yes. Now let's continue. We have P, parallel lines. Do we have any parallel lines? No, we don't. T, tangent. Do you have any tangent? No, we don't have a tangent, but we can also use the theorem angle at the center is 2 times angle at the circumference. So this angle here at M will be 2 times 38, right? Yes. Now, we are done with our analysis. Let's quickly go to the questions and see what we are required to find. Now, calculate with reasons the size of the following angles, right? With reasons. Remember, if you don't provide the reasons, you won't get the full marks. So you have to provide the statement and the reasoning that accompanies the statement or that supports the statement that you just mentioned. So now we want to find the angle of KMA. KMA, we said KMA is equal to, so when you write it on your answer sheet, you will say KMA, and don't forget to put that head there to show that we are talking about that angle there at M. So we are saying KMA is equal to 2 times 38. So let me quickly punch my calculator to avoid doing some careless mistakes. 2 times 38 is equal to 76. And not just 76, because here we are talking about angles. So it is going to be equal to 76 degrees, right? 76 degrees. Now, what is the reason behind that? It is that angle at the center, angle at the center is 2 times angle at the circumference. So now you will definitely get your full marks for the statement and the reason 2 marks. Now you're okay. Okay, let's move to the next question. Question B. We are required to find the angle T2. Okay, how are we going to find that T2? In order for us to find that T2, okay, we said this is a quadrilateral. Remember, we had that theorem somewhere that said if this is a cyclic quad and you have some line that is produced somewhere here, this angle here is equal to that angle there. Reason being, an exterior angle of a cyclic quad is equal to interior opposite angle. So angle T2 with a head to show that this is an angle. So if you write it with only T2, that is incorrect. You have to write it as an angle T2 is equal to 38 degrees. From that 38, this is a cyclic quad with the line that is produced here. So this angle here is equal to that angle right there. So T2 is equal to 38 degrees, reason being exterior angle of a cyclic quad is equal to the interior opposite angle. Then you are done. So because this is maths, there are many approaches to approach a problem. There are many ways to kill a cat. You can also use this approach. We said this is a cyclic quad, and opposite angles of a cyclic quad are supplementary. So angle B plus angle T1 is equal to 180 degrees. So we have a head, angle B, we have a head, angle T1 is equal to 180 degrees. Why? Because opposite angles of a cyclic quad they are supplementary. Now, what is B? B is 38 degrees. Angle T1 is equal to 180 degrees. Now, I make my angle T1 subject of the formula, 180 degrees minus 38 degrees. T1 is equal to 180 minus 38, right? I get 142 degrees. Okay, now I want T2. Now we notice that this is an angle on a straight line. Therefore, angle T2 plus angle T1 is going to be equal to 180 degrees. Angle T2 plus angle T1 is equal to 180 degrees. Why? Because those are the angles on the straight line. Those are the angles on the straight line. Now, T2 is the one that we are looking for, plus T1 is 142 degrees is equal to 180 degrees. Now, angle T2 is equal to 180 degrees minus 142 degrees. Angle T2 is equal to 180 degrees minus 142. I get T2 is equal to 38 degrees. Now you get the same answer as this one, since there are many ways to kill a cat. Now let's proceed to the next question. Question C. We are required to find the angle C. Where is C? C is there. We said when we were using Dr. Cape Town theorem that C is equal to B because they form this tie because angles in the same segment. So C is equal to B. They are both equal to 38 degrees. So reason being angles in the same seg. Fine. Let's go to the next one. D. We want the size of angle K4. Now, where is K4? Here is the K4 that we are looking for. Here is K4. How are we going to find that K4? Let me think. Okay, it is still not bad because I'm trying to have a look on this quadrilateral here. And this quadrilateral here, it is a cyclic quadrilateral. Let's do this. This is a cyclic quadrilateral. This is a cyclic quadrilateral. This one. With 1, 2, 3, 4 corners on the circumference, right? So this angle K4 will be equal to that angle A. Why? Because of the exterior angle of a cyclic quad is equal to the interior opposite angle, right? Now, how can we find the size of this angle? Remember, we were given at first that NA is equal to NC. Therefore, NCA is an isosceles triangle. Therefore, this angle here is also equal to that angle because NCA is an isosceles triangle. Now, how can we find A? Since this one is 38, A will also be 38. Then now you will say, what is happening with my pen now? I'm sorry for that. Okay, there we go. We will say angle, oh no, I was using the red pen to answer that. So angle A is equal to angle C. They are both equal to 38 degrees. Why? Because they are the base of an isosceles triangle. Then now K4 and an angle, not just K4, but an angle K4 is equal to an angle A. They are both equal to 38 degrees, not just 38, 38 degrees. Why? Because that is an exterior angle of a cyclic quad is equal to the interior opposite angle of this cyclic quad, right? Yes, now we are done with answering these questions up to D. Now let's proceed to the next one, which is 10.2.2. Now, we are required to prove that NK is this one, is equal to NT. How are we going to do that? K4, isn't it equal to T2? Isn't it? Because those are the basis angles. These and these. Are they not equal? Yes, they are equal. Now, you definitely say K4 is equal to angle, not just T2, but an angle T2. Then those are the base angles. Excuse me. The base angles are equal. Therefore, NK is equal to NT. Now let's go to the next one, which is the last one of this lesson. Now we are required to prove that a quadrilateral AMKN. What is AMKN? AMKN. AMKN. This is AM. Okay, this one. We want to prove that this is a cyclic quad. How are we going to prove that? So, how can we find an angle N? We have the size of that angle. If maybe we can have the size of the angle N here, we can maybe sum them up with that one and see if maybe they give us 180 degrees since they are opposite angles. Now let's see maybe if we can find the size of this angle N. But how are we going to find this angle here? This one. Oh, we can. How are we going to find that? This and this and this, when we add them, we get 180 degrees since those are the interior angles of a triangle. Now, angle N is equal to 180 degrees minus 38 minus 38. Reason being, the interior angles of a triangle are supplementary. Now, angle N is equal to 180 degrees minus 38 minus 38. I get 104 degrees. Okay, now we found this 104. 104. Now, what are we going to do next? This AMKN. AMKN to prove that this is a cyclic quad. So now when I take this angle N plus that angle M to see if maybe I will get 180 degrees to support using that reason of opposite angles of a cyclic quad. I don't win because 104 plus 38 is not 180 degrees. It is 142. Now we need to go and try another approach. Now, how are we going to approach this? Okay. Okay. How? Oh, my bad. KMA, it is not 38, but we found it here. It was 76. So yes, we can use that. Now N plus KM A. What is N? It is 104. What is KMA? KMA, it is equal to 76 degrees. Now let's sum that up. 104 plus 76. I exactly get 180 degrees. Therefore, this is the converse of opposite angles of a cyclic quad are supplementary. Then you are done with every question that you were required to answer there. Okay, now let's proceed and have a look on this. Oh, this one is going to be long and it is going to take us time for this 7 minutes. Let's just end this lesson here, guys, and then I will see you on the next lesson. Thank you for joining.